do a bit of dissection and etymology with the word kinematic. It comes from the Greek word kinesis, which is in turn from kinein. I'm sorry if I'm pronouncing that wrong. Both of the words have to do with motion, so we see that kinematics is the science of motion. Let's take a look at the science of motion today. Hi guys, and welcome back to Fast Physics with your host Maggie, who is neither a linguist or a physicist. I'm Maggie, 1 month from being 16 and eons and oceans and fathoms away from knowing what the heck I want to do with my life. So what are kinematic equations and how do we use them? Well, like we saw earlier, kinematics deals with motion. So kinematic equations are equations that deal with motion, but only where acceleration is constant. Let me introduce them to you guys today and give you a mnemonic device for them. There are 4 generally used kinematic equations. Final velocity equals initial velocity plus acceleration times time. Displacement equals half of acceleration times time squared plus initial velocity times time. Displacement equals the sum of final and initial velocity divided by 2 times time. And finally, final velocity squared equals initial velocity squared plus 2 times displacement. Phew, so how the heck are we supposed to remember all of them? Well, you actually don't have to have them all memorized. You can always look them up online or derive them, and 3 of the 4 are actually on the AP Physics formula sheet. But it doesn't hurt to cover them a bit more in detail and to have a good mnemonic device to help you remember them. So let's first look at what all of those variables mean. V subscript f stands for final velocity and sometimes written without the f. V sub naught or I is initial velocity and a is pretty reliably acceleration. Once again, the acceleration has to be constant for these equations to work, and we'll go into why that is in my next video. T is a change in time, so if you're given the final and initial times, you'll need to find the difference to get T. And finally, delta x is displacement. If you guys will remember from a few videos ago, delta means change in. So sometimes instead of delta x for displacement, we'll get x subscript naught or I for initial position and x subscript f for final position. When these are there instead of delta x, the initial position is usually being subtracted from the final position to get that total displacement. Hopefully that wasn't too awful. Most of the variables that we are using start with the same letter as the thing that they represent. And as long as we remember that x is an object's position, we will remember displacement as well. Remember the equations is a little bit harder. If you've memorized them already without a mnemonic device, I just want to know how, but I bequeath them to you freely, and you may skip the next few minutes of this video and go on to watch my next video. For the rest of us, here's my mnemonic device for the 3 equations that are on the AP Physics formula sheet. So I imagine Victor Crumb telling Hermione Granger this story because he has a Bulgarian accent. What with half of the 80s being displaced by a tale of 2 squares and 2 axes, the final 5 are just the first 5 but at the end. So the O in what, which is just what in a Bulgarian accent, I'm sorry that my Bulgarian accent is so bad, makes it initial velocity times time, and 80s sounds like AT with an S at the end. Hopefully that helps you remember that time is being squared. Displaced is kind of self-explanatory. It stands for displacement. A tale of 2 squares is because both final and initial velocity are being squared, and they're being separated by the equal sign. The initial velocity squared is also being added to 2 times acceleration times displacement, which looks like 2a delta x. So I think of the a and the delta x together as an ax, and there are 2 axes because it's being multiplied by 2. V is a Roman numeral for 5, and so the final 5 refers to V sub f, which is final velocity, and R means equals, so that's our equal sign. The first 5 once again works with the Roman numeral V, and first means that it's our initial velocity. At is acceleration times time, or AT, and the end tells us that the equation is now over. That's just my personal trick though. If you guys have others, I'd love to hear about them. Tell me down in the comment section below. Thank you for watching this video, and subscribe and turn on post notifications so that you'll know when my next video, which is about deriving kinematic equations, is out. Thank you for watching again. Bye!